The mode source can be used to inject the mode of a waveguide or fiber. The mode source includes an integrated mode solver which uses the finite difference eigenmode solving algorithm to calculate the field profile of the supported modes of a given structure cross-section. If you're interested in learning more about the mode solving algorithm, see the reference paper listed below. The mode solver assumes that the cross-section of the structure is constant along the propagation direction, so it cannot be used to solve for block modes, which are 3D modes of a waveguide that has periodicity along the propagation direction, such as the photonic crystal waveguide like the one shown here. To set up the mode source, the source should be positioned over the cross-section of the waveguide or fiber. The simulation mesh of the FDTD solver region is used as the grid over which the supported modal fields are calculated. So to increase the spatial resolution of the calculated mode profile, the simulation mesh can be made finer. The mode source settings allow you to specify whether you want to find the mode for a straight or bent waveguide with a given bending radius, and also specify rotation angles to match the angle of the waveguide if the waveguide is not aligned with the X, Y, or Z axis. You can choose to inject the fundamental mode, which is the mode with highest effective index, or the fundamental TE or fundamental TM mode, which correspond to the mode with highest effective index, which has the desired TE-like or TM-like polarization. In FDTD solutions, TE-like modes correspond to modes where the electric field is polarized primarily along the Y direction for sources injected along the X-axis, and primarily along the X direction for sources injected in the Y or Z axis directions. You can also choose the User Select option, which allows you to click on the Select Mode button to open up a new window where you can specify advanced mode solver settings, such as the number of trial modes to use and the effective index to search near, as well as custom boundary conditions for the mode solver region. After calculating the modes using the specified mode solver settings, modes will appear in the mode list at the top of the window. You can select a mode from the mode list to plot the field profile of the mode. You can also see details about the calculated mode in the mode list table, such as the effective index of the mode, loss, and polarization fraction. The formula for the polarization fraction calculation and waveguide TE/TM polarization fraction are listed on this slide. Additional information about the calculations can also be found on the knowledge base page linked below. Some applications where the mode source can be used is in fiber optic simulations and simulations of integrated optics components such as waveguide couplers, ring resonators, and Y branches. A main application where you would want to inject the supported mode of a waveguide is for extracting the S parameters of an integrated optics component. Instead of using the mode source, ports can be used. Port objects are used especially for S-parameter extraction, and ports act as both mode sources as well as monitors to calculate and return S-parameter results, simplifying the process of S-parameter extraction. Port objects will also be introduced in more detail in the monitors section of this course. In the next unit, we'll demonstrate the setup of a mode source for an asymmetric directional waveguide coupler.